The old ones, ठीक है? This is moles के. It's just going to have more moles questions, ठीक है? Starting with the first part. This thing you can probably do this, ठीक है? That's O levels, ठीक है? कि relative mass, वो सारा. You can do that. Define the term relative atomic mass, ठीक है? I just sent you a sheet जिसके अंदर you had a lot of definitions. The relative atomic mass की definition that's written over there, it's the average mass of an atom compared to 1/12th the mass of a carbon-12 isotope. The relative atomic mass of magnesium is 24.3. Calculate the percentage abundance and hence the relative isotopic mass of the third isotope of magnesium. Give your answer. अच्छा, so there's, तो ये quickly कर लें कि you've got three isotopes, magnesium 24, magnesium 26, and there is some third isotope which we have no idea of. ठीक है? We have no idea what the third isotope is. अब ये कि just a second. अच्छा, now the third isotope. ठीक है, let's call that magnesium with an isotopic mass of X. Abundance कितनी होगी? The total abundance is 100%, so 79, 11, that's कितना? That's 90%. So this is going to be what? 10%, ठीक है? And what you can do is कि you know what the AR is. ठीक है? How do you calculate AR? That's the relative atomic mass U. Take the isotopic mass multiplied by the percentage abundance. Take the other isotopic mass, which is 26, and multiply it by the percentage abundance. Take the third isotopic mass, which you don't know what it is, and multiply it by the isotopic abundance and divide by 100. Okay? The AR is already known, that's 24.3. All you have to do is you have to solve this and you'll figure out what the answer is. Okay? So X can be found out this way. Now the next part is magnesium can be as electrolysis. That's not in your course. An investigation of the reaction between magnesium oxide and hydrogen chloride gas showed that an intermediate product was found with the composition by mass of this thing. So calculate the empirical formula. So what is the first thing that you do? Empirical formula, you divide by the relative isotopic mass. So you want it, and this is 35.5. वैसे कुछ जल्दी से बता दे कि sometimes you get stuck with the ratio in the empirical formula. तो इसका क्या आ रहा है? What do you get for this? कि पहला पार्ट क्या है? 31.65 divided by 24.3.
1.30, sir.
Okay, that's 1.30. What's this one? 20.84 divided by 16.
Also 1.30, sir.
So this is 1.31, which is approximately the same. And what is this one? You have 1.30.
Yes.
So basically the one, that's easy. 1:1. Everything is 1:1. As an acid-base behavior of the oxides in the third period varies across the. How does it vary? TK acid-base behavior. Okay. No, first two are basic, strongly basic. The third one, Al2O3. Can't get up here. Notes. Yes, just a second. As an acid-base behavior. Sodium oxide, magnesium oxide are basic. Equal. So sodium oxide, magnesium oxide are basic. They will react with acids. Al2O3 is amphoteric. You should know the equations for both reactions. And the rest of them, non-metal oxides, they are basically SiO2 is weakly acidic. The other ones, phosphorus and sulfur, are strongly acidic. Okay. So यहाँ पे वो क्या कह रहे हैं? यहाँ पे कह रहा है describe this behavior and explain it with reference to the structure and bonding. So acid-base behavior in the third period across the. So the first one is sodium oxide. So uska behavior explained with reference to structure and bonding. So or NaL2O3, right? और SO3 ये दोनों जो है that's this one is amphoteric, this one is basic, while SO3 is acidic. ठीक है, स्ट्रक्चर एंड बॉन्डिंग उनकी डिस्क्राइब कर दो साथ ही. दिस वन इज सिंपल मॉलिक्यूलर. they're not asking you to make equations, so this one is simple molecular and these two are basically ionic. ठीक है, अच्छा एक एक ऑक्साइड का पता होना चाहिए कि which one is मतलब यहाँ पे ना, remember metal oxides, these ones are ionic. SiO2, that's a giant covalent structure. This one, these are simple molecular. Chlorides
Sir,
yeah.
Sir, when we're writing these answers, should we write them in points?
No, points perfectly fine. Points अगर वो clearly points are preferred. ठीक है, but एक point होगा कि SO3 is acidic and it is a simple, sorry, covalent नहीं लिखा, covalent क्योंकि उससे कहा था bonding and structure, right? So मतलब proper sentence हो कि SO3 is acidic and it is a simple covalent. It's got a simple, it's covalent and it's got a simple molecular structure. ठीक है, मतलब इसको वो एक point हो गया. Na2O3 and Al2O3 are what? They are ionic and they have a giant lattice. ठीक है, ये bonding होगी and this is your structure. फिर ये एक point होगा कि Na2O is basic, it's a metal oxide. Al2O3 is amphoteric. ठीक है, मैं वो सब बता देता हूँ, right? Equations for reactions of these three oxides with hydrochloric acid and or with sodium hydroxide as appropriate. So I said the reactions with hydrochloric acid. So Na2O is basic, it will react with HCl, it will form NaCl plus H2O. So then you have Al2O3 that will react with both. Well, basically वहाँ पे equations लिखी हुई है, वही लिखनी है कि Al2O3 कहाँ गई है? Al2O3 will react with both. It will react with HCl to form AlCl3 plus H2O. Al2O3 will react with NaOH. Hot concentrated sodium aluminate would be formed in water. That's SO3, that's acidic, that will react with NaOH. It will form sodium sulfate and a water molecule. तो ये चीजें प्रोड्यूस होंगी. ठीक है, ये इक्वेशंस you have to remember. अच्छा, मोल्स का कोई क्वेश्चन यहाँ पे आ रहा है कि नहीं आ रहा? Write an equation for the reaction of galena and oxygen to form sulfur dioxide and lead two oxide. तो वो कह रहे हैं कि it is manufactured by the contact process. The first stage of it, so the first stage of which involves the conversion of sulfur or a sulfide ore, such as galena, that's PBS. और वो कह रहा है oxygen के साथ reaction है. To form what? Sulfur dioxide, that's SO2. And lead 2 oxide, lead 2 means Pb is plus 2, oxygen is already minus 2, so that's PbO. Identify the oxidation numbers changes that take place during this reaction. So Pb jo hoga, that's probably plus 2 and S is minus 2. So S goes to plus 4. So ek the oxidation state should change over here, that's S going from minus 2 to plus 4. मतलब point में लिखोगे आपके sulfur या PBS में आप बताओगे कि भी sulfur is minus 2 while उसके अंदर ना sulfur is plus 4. SO2 के अंदर sulfur is, your sulfur is actually plus 4. अच्छा, और किसकी change हुई इसमें? Whose oxidation state changed? What is the other element whose oxidation state is changing in this
Oxygen.
case? ठीक है, oxygen जो था वो पहले 0 था, वहां जाके it's minus 2 in both of them. ठीक है, तो वो आप explain करोगे. NO2 oxygen is 0. So SO2 and PbO, the oxygen is minus 2. I said state the temperature usually taken for this conversion and explain contact process की क्या conditions होती थी.
Say low temperature or high pressure.
ठीक है, state the temperature usually chosen explain this in terms of rate. हाँ, exact temperature क्या होता है पहले ये बताओ.
450 degrees Celsius, sir.
कौन सी?
450 degrees Celsius, sir.
ठीक है, 450 डिग्री सेंटीग्रेड. ठीक है. अच्छा, इसमें फिर से कोई एंटर तो नहीं हो गया कोई? सी कोई वेटिंग रूम है तो वो अच्छा दिस वन. अच्छा चलो मुझे कोई बता देना कोई अगर वैसी कोई एक्टिविटी कोई हो रही है. अच्छा दिस वन 450 डिग्री सेंटीग्रेड. ठीक है. सो यू हैव टू जस्टिफाई यूजिंग द शैटलर प्रिंसिपल. व्हाई नॉट अ हायर टेम्परेचर? व्हाई डोंट दे यूज अ हायर टेम्परेचर?
सर फिर इक्विलिब्रियम बैकवर्ड शिफ्ट कर जाएगा क्योंकि फॉरवर्ड एक्सोथर्मिक और बैकवर्ड एंडोथर्मिक.
ठीक है. सो इट्स एन एक्सोथर्मिक रिएक्शन, सो हायर टेम्परेचर द इक्विलिब्रियम विल शिफ्ट बैकवर्ड्स. ठीक है. So your backward reaction will be favored and your yield would drop. ठीक है. So yield will drop, right? That तो ये हायर टेम्परेचर पे हो रहा है. हायर टेम्परेचर का फायदा क्या है वैसे?
सर रेट
Rates
ऑफ
of
रिएक्शन
reaction
फास्ट.
are high, sir.
ठीक है. You get a faster rate of reaction. ठीक है. So there's a faster rate, but your yield will decrease and backward reaction will be favored. Why not a lower temperature? Lower temperature कौन से को favor करेगा?
सर फॉरवर्ड.
ठीक है. Lower temperature will favor the forward reaction. It will favor the endothermic reaction. So that means your yield increases. नुकसान क्या है lower temperature? Why don't you use a lower temperature?
सर कॉस्ट ज्यादा पड़ेगी. सर कॉस्ट ज्यादा होगी बनाने की.
नहीं, lower temperature slow rate होगा ना. ठीक है. You're going to get a very slow rate. Is that clear? Or higher temperature में you were getting a faster rate. That was a good thing. लेकिन it was favoring the backward reaction. ठीक है. So remember Lee-Shatler principle में it's not just the Lee-Shatler principle के forward or backward is favored. You have to look into the rate of reaction. Pressure conditions अब वो कह रहे हैं, सीधा explain करो. Which that would give the best rate and best yield of. So explain why these conditions are not actually used. So best rate and best yield. Pressure क्या होना चाहिए? High या low?
सर हाई प्रेशर होना चाहिए.
So if you have a high pressure, that means particles are explain भी करना. ठीक है. Whenever they write explain, you have to explain fully. ठीक है. So when you have a higher pressure, तो क्या होगा? Particles you'll have a lesser volume. And if you have a अच्छा high pressure के ऊपर you'll have a lesser volume. Lesser volume का मतलब है कि particles are closer together, which is why what will happen is कि high pressure के ऊपर you will get a faster reaction. Why? Because you're going to get more frequent. If they're close together, you're going to get more frequent collisions. ठीक है. So higher pressure would give you a better rate of reaction. तो एक सेकंड है ना ये में. अच्छा, the other thing is where would the equilibrium shift? Higher pressure के ऊपर what is the rule?
सर हाई प्रेशर पे लो गैस मोल साइड फेवर होना चाहिए.
ठीक है. तो higher pressure favors less gas moles. अच्छा, less gas mole side is favored, which means in this case it's going to be the forward reaction. क्योंकि अगर ऊपर reaction देखो तो it is going to be the forward reaction, less gas mole side. So that's also so you're going to get a higher yield. So Le Chatelain principle भी कह रहा है कि भी higher pressure, और वो भी कह रहा है rate of reaction भी कह रहा है higher pressure. तो क्यों नहीं use करते? What's wrong with using a higher pressure?
Sir, can you say because it's expensive to make the pipes used in the reaction?
ठीक है, so your cost increases, that's why. ठीक है, it's harder to maintain a higher pressure, so your cost increases, which is why you don't use a higher pressure. They explain why the sulfur trioxide is not dissolved directly in water to produce sulfuric acid. So, क्या होता है? What's the contact process? The first step is as sulfur is burned, it produces SO2. The next step was this one, that the SO2 is then further reacted with O2 to form SO3. इसमें क्या होता है? The conditions are 450 notes with the nitrogen sulfur, 450 centigrade, and it's 2 to 3 atmospheres, and there's a catalyst which is B2O5. So ये सारे. Now the thing, I explain why the sulfur trioxide is not dissolved directly in water. Why is the sulfur trioxide not directly dissolved in water to form sulfuric acid?
Sir, highly exothermic reaction.
ठीक है, it's a very explosive, highly exothermic reaction, so that's why it's not done. Instead, what they do is they make oleum, or oleum के बाद they dissolve it in concentrated sulfuric acid. ठीक है, so this is not done. It forms, and then oleum is diluted.
Sir, can I just answer using the equations in this case?
You have to explain that why it's not directly dissolved. I mean, he didn't ask for the equations.
But
Okay.
I still can use it for. I still can use it, yani.
No, you can, but he's not. Firstly, he has never asked about this. ठीक है. वो तो मैं वैसे ही, I was just explaining this. What he had asked was, why does sulfur trioxide not dissolve directly in water? So you're just going to write that it's just 1 mark. So you're just going to write it's a highly explosive exothermic reaction. Now he's asking for the reaction of sulfur. Now he's asking for those equations. Okay, now you write those. Now, why is sulfur dioxide? What's the use of sulfur dioxide? Why is it used in?
Sir, it can act as a preservative, so it can kill bacteria and pests. Sorry.
It can act as a food preservative. It has 2 uses. Doesn't even know what the other use is.
Fertilizer, sir? In fertilizers?
Okay, so, no, it's not.
Is it something to do with reducing agents, sir?
Achha, so it's food preservative, and वो जो reducing agent है ना, उसका part है. You have to explain it. So it's a good reducing agent. Achha, so it's a good reducing agent. अब ये फिर भी. It's a reducing agent. That's why it's a good food preservative, because reducing agents, they get oxidized. So they use up all the oxygen themselves. Food preservative is like the bacteria doesn't get, like if you have a can and there's a lot of oxygen in it, the bacteria is going to use that and it's going to multiply by using that oxygen. What sulfur dioxide does is that it turns into sulfur trioxide, uses up all the oxygen. That's why it's a good food preservative. There's another use, which is that it bleaches wood pulp. Okay? So the moles question. You've got this reaction. He's saying that 50 cm cube sample of wine is required. This much concentration for complete reaction with SO2. How many moles of SO2 are present in 50 cm cube of wine? So first thing, how many moles of iodine do you have? You've got कितने moles are इसको calculate करो. Concentration times volume, that's 0.010 times 12.35. Divide by divide by 1,000.
Say 1.235 into 10 raised to power minus 4.
अच्छा 10 power minus 4 moles. So I think SO2 will also have exactly the same moles because it's 1:1, right? So that's SO2 in 50 cm cube of wine. Okay, now he's saying that 1 dm cube mein kitne? So in 50 cm cube, you've got this much, which is 1.235 times 10 power minus 4. So 1000 cm cube mein kya hoga? 1000 cm cube mein it's going to be x, and you're going to cross multiply. So what do you get?
Say 2.47 raised to power minus.
Minus? नहीं किया, minus कितना है?
Say 3.
That's -3. फिर how many milligrams of mg of SO2 are present in 1 dm cube wine? Give your answer to. So he's asking for the mass in milligrams. So what's the mass in grams, by the way? It's going to be 2.47 times 10 power minus 3 multiplied by the MR of SO2, which is 64.1. This will be in grams.
0.158.
Hmm?
0.158.
But that's in grams, okay? But in milligrams, it's going to be multiplied by 1,000. So jo bhi, I think 158 milligrams, right?
Yes.
सर हमने इसको मल्टीप्लाई क्यों किया 69.1 से
64.1 से MR से ना,
ओके ठीक ठीक
ठीक है?
जी।
अच्छा एक वो कर रहे थे, इसमें फिजिकल के क्वेश्चन ज्यादा करते हैं, ठीक है? बॉन्ड एनर्जीज एक्सेट्रा पुराने जो थे ना पेपर्स में, यू गॉट अ लॉट मोर फिजिकल, ठीक है? जस्ट टू बी, क्योंकि लास्ट 3 years इट्स जस्ट मोस्टली इनऑर्गेनिक एंड ऑर्गेनिक, तो शायद मे बी फिजिकल थोड़ा ज्यादा आ जाए इस दफा, तो जस्ट टू बी on the safe side. So bond energies, how do you calculate enthalpy change using bond energies? It's bonds broken, ठीक है, reactants में. So how many bonds are broken? C2H6. C2H6 is this thing. ठीक है, carefully count the bonds. So how many bonds are being broken? That's you're breaking one carbon-carbon bond. You're breaking कितने 6 C and H bonds, ठीक है? Bonds broken is all positive, ठीक है? And how many bonds? And there's a Cl-Cl bond as well that's being broken. So then how many bonds are being formed? C2H5Cl. So bonds being formed, that's one CC bond that's being formed. ठीक है, minus में होगा, you're forming 5 CH bonds. You're forming one CCl bond. फिर एक HCl का bond भी form कर रहे हो, ठीक है? You're forming that as well. So उसमें a lot of these bonds will get cancelled out, ठीक है? If you sum them up, ठीक है? So ये HCl है bottom पे. Enthalpy का डेटा में डेटा बुकलेट में गिवन है, ठीक है? अब तो साथ ही होगा क्वेश्चन के. तो किस किस का पता करना है? You have to अच्छा, CC is 350. उसका चाहिए नहीं था, ठीक है, that's going to get cancelled out anyways. CH is basically you need, I mean the 5 CH will get cancelled out. There's only going to be 1 CH left. So CH is what? CH is 410. ठीक है, so your CH is 410. CLCL, what is CLCL? That's 242, ठीक है, that's given over here. फिर HCl, ठीक है, you need that. HCl is 431 और वो माइनस में होगा, नहीं सॉरी ये था, ये CCl था, सॉरी HCl ऊपर है. And then you had CCl. CCl is what? That's 340. तो इसको सम अप कर लेते हैं कि that's 410 plus 410 plus 242 and bonds being formed on the other side, that's minus 431, and the other bond that's being formed is minus 340. ठीक है, the rest all got cancelled out. ठीक है, the CC bond got cancelled out on both sides. The CH bond, most of them got cancelled out except for just one. अच्छा, क्या वैल्यू आ रही है? What do you get for this?
Sir, minus 190.
ठीक है, minus 119. State the conditions needed for this reaction to occur. ये कौन सा reaction है organic chemistry में? Which reaction is this?
Sir, free radical substitution.
ठीक है, this is free radical substitution. Use a series of equations to describe the mechanism of this reaction, including the names of each stage and the indication. So what happens in, मतलब इसका कर लेते हैं, free radical substitution. What happens? First step क्या होगा?
So initiation.
ठीक है, so the first step is initiation. What happens in it is that the CL-Cl bond breaks and it results in the production of Cl radicals. हाँ, arrows वगैरह उसने ही show किया, so forget that. ठीक है, just write equations. So then you have propagation. And in the propagation step, what happens is that the Cl radical बल्कि उसको इकट्ठा करके लिख लो. You don't have to draw curly arrows. He didn't ask for that. ठीक है, so so you've got C2H6. The Cl radical comes in, steals one of the H's, and it becomes C2H5. And HCl gets formed. This carbon is a radical now. Next propagation step, this C2H5 radical, the carbon is short of one bond, it will attack a Cl2 molecule and it will become C2H5Cl. It will gain and another Cl radical gets produced. And the propagation step will continue, and then you have a termination step. Termination में क्या होता है? Termination में any of the radicals would simply combine. So you have a C2H5 radical combining with a Cl radical, and they would form C2H5Cl directly. Or you could have two C2H5 radicals, and they would form a butane molecule, which is C4H10. ठीक है, तो ये आपके initiation propagation 5 marks हैं. ठीक है, remember mechanisms are important because उसके हमेशा it's always 3, 4, 5 marks. ठीक है, usually it's nothing less than 4 marks. अच्छा, अगला part. चलो organic अभी हम skip करें. ठीक है, we'll just focus on physical chemistry questions right now. ठीक है, तो ये भी कौन सा किया था हमने? Summer 15. अच्छा विंटर का कर लेते हैं. अच्छा define the structure of solid aluminum metallic bonding. ठीक है, it's positive metal ions in a sea of free moving electrons. Aluminium के uses जो है ना, uses में क्या? Aluminium is a very good conductor of electricity. Why? Because it's got a lot of delocalized electrons, high voltage power transmission. Another good thing about aluminium is that it's unreactive, which is and light. तो airplanes वगैरह ना, और unreactive है तो you also make cooking utensils out of it. Structure of a ceramic material. Ceramic materials are ceramic जो है ना, जो word है ना, that is for substances that have very high melting and boiling points, are structurally very, very strong. So ceramics जो होते हैं ना, they're usually giant structures, giant ionic or giant covalent structures. So they're giant structures with strong covalent bonds. तो कौन सी property high melting and ceramic materials की properties क्या होती हैं? High melting and boiling points. They're insulators. They don't conduct electricity. ठीक है, तो ये कुछ उसकी properties है. फिर वो कह रहे हैं aluminium reacts with chlorine to form a white solid chloride that contains 79.7% of chlorine and sublimes changes straight from a solid to a gas at 180 degrees centigrade. So can I describe the structure and bonding in this compound and suggest how this explains the low sublimation temperature? So just structure and bonding, ठीक है? Aluminium chloride, remember, is bonding उसकी बताना है. Remember, stick to be very brief, ठीक है? The bonding is that it's covalent. Structure is that it's a simple molecular structure. ठीक है, सिर्फ ये. Or explains why do they have a low sublim? Because they've got weak intermolecular forces. That's it. ठीक है, या weak van der Waals forces, which require very less energy. Empirical formula आप निकाल लोगे, उसकी बाकी information तो दी हुई है. So you can find the empirical formula. ठीक है. So calculate the empirical formula of the chloride. You must show your working. वो तो हो जाएगा. This is PV to NRT. ठीक है. Find, calculate the MR of the chloride. So you're given a bunch of information about this thing, and you can find the. You can find the MR. तो अच्छा MR निकालनी है. So all you have to do is PV is equal to NRT. Pressure क्या है? 100. It should be in pascals, so 100,000. Volume is 200 cm cube. That should be in meter cube, so that's 200 times 10 power minus 6. N is mass over MR. Mass given at 1.36 grams. So moles is mass over MR, which is what we are looking for. R k 8.31. And the temperature is given, that's 200 centigrade, but it should be in Kelvins. So it should be in Kelvins. And since it's going to be in Kelvins, तो यहाँ पे क्या होगा? That's going to be 200 plus कितना हो जाएगा?
273.
273. तो इसकी MR फिगर आउट करनी है. तो इसकी MR कैलकुलेटर क्या आएगी? तो वो कर लेना, ठीक है. वैसे कोई कैलकुलेटर बता दे कि MR क्या बनेगी.
Say 267.3.
अच्छा 267.3. I said use the molecular formula of the chloride 267, so that's going to be Al2Cl6. मतलब वो aluminium chloride की बात हो रही थी. लेकिन remember aluminium chloride forms a dimer, ठीक है? MR उसकी aluminium chloride दो types के होते हैं. One is AlCl3, the other one is Al2Cl6. ठीक है? So there are two types of aluminium chlorides. 267.3 is for 133.5 होता है. 0.3 भी आ रहा है.
So 0.28 उसको round off कर दिया था.
अच्छा चलो ठीक है. अच्छा the other part is कि अच्छा enthalpy change of formation की definition. What's the definition enthalpy change of formation? It's the ये सारी वो sheet मैंने भेजी है. उसके अंदर the definitions are given. So explain the meaning of the term enthalpy change of formation. क्या होता है? It's the energy released or absorbed. It could be positive or negative, endo or exo. When 1 mole of a substance is formed from its constituent elements, and the elements have to be measured under standard conditions. So that's your enthalpy change of formation. Now give the equation for the reaction for which the enthalpy change corresponds to the standard enthalpy change of formation of liquid SO3. ठीक है? So liquid SO3 including the 1 mole of SO3 liquid is supposed to be formed from its constituent elements. क्योंकि ये दो है. Standard conditions में ये वाला element जो है that's a solid. So the next part is फिर से बॉन्ड एनर्जी का क्वेश्चन आ गया. ठीक है? ये बहुत सारा फिजिकल अब नहीं आ रहा वैसे. How many bonds are broken? How many bonds are formed? You're breaking an N triple bond N. You're breaking 3 HH bonds. वो सारा प्लस होगा. And you're forming 6 NH bonds. वो सारा माइनस होगा. ठीक है? तो डेटा बुकलेट में से N triple bond N is this one is what? Double bond N and triple bond का. That's 944. HH कितना है? HH is अच्छा HH is 436 and minus 6 NH. तो 390 है. तो इसको सॉल्व करोगे you'll get your answer.
So negative ETH.
कितना आ रहा है?
Negative ETH.
अच्छा हेबर प्रोसेस की क्या वो नाइट्रोजन सल्फर 450 degree centigrade is the condition. 200 atmosphere is the pressure. और आपको क्या चाहिए? You need an iron catalyst. और फिर से we explain करना है कि temperature, why did he use why not a height? It's an exothermic process. ठीक है? ये देख लो पुराने पेपर्स के अंदर you had a lot of physical. ठीक है? Latest के अंदर you don't have a lot of physical. ठीक है? तो it's an exothermic reaction. Again, why not a higher temperature? Higher temperature would favor the endothermic, which is the backward. The advantage of using a higher temperature is you're going to get a faster reaction, but it's going to favor the backward reaction. What about lower temperature? Lower temperature, it will favor the exothermic reaction, but the reaction would be too slow. So वो justify करनी है 4 mark की justification है. As anyways, physical. Let's move to inorganic. छोड़ो. Moles का एक question कोई ये inorganic आ गई. अच्छा मोल्स का कोई बहुत पुराने पेपर में चले जाते हैं. अच्छा पूरा ये 12 mark moles question, ठीक है? So let's try and do this one. The question is sample of fertilizer ammonium sulfate. There's a fertilizer that's got ammonium sulfate and it's got sand. So 2.96 grams of the solid fertilizer was heated with NaOH and excess, and all the ammonia produced was boiled away. So fertilizer ये ammonium sulfate, so you can make an equation of that. Ammonium salts की equation होती है with NaOH. What happens? के the OH ions, they gain H+1 from ammonia. It's an acid-base reaction. So ammonia produced होता है, plus water gets produced. And you've got Na2SO4 as the salt. इसको balance कर लो. अच्छा तो उससे क्या है कि 40 cm³ of excess NaOH, excess में NaOH is being added. So excess, so that means a lot of it is not used. After cooling, the remaining NaOH was neutralized by HCl. So ये जो remaining NaOH है ना, which is leftover NaOH, that is reacted with HCl and it forms NaCl plus H2O, ठीक है? तो ये पूरी reaction की scheme है. You had fertilizer which had some ammonium sulfate. That ammonium sulfate was reacted with an excess of NaOH. When the NaOH was left even after the reaction, that was reacted with HCl and is given you the volume and concentration of the HCl. तो कितने moles हैं HCl के? ये कितना बन रहा है?
0.059.
अच्छा 0.059 moles. ठीक है, so the exact 0.059 or 0.06 round off करके क्या आ रहा है? ये आ रहा है, exact ये आ रहा है वैसे 29.5 times 2.
Exactly.
हाँ ठीक है, so you got 0.059 moles, right? So leftover NaOH कितना होगा? That's also going to be 0.059 moles. As he then states that the original 40 cm³ of NaOH in a separate experiment, so in a different experiment, this original NaOH, the original NaOH that you added over here, this original NaOH was neutralized by HCl, and uska bhi वही reaction होगा. It's going to be NaCl plus H2. So in a separate experiment, this 40 cm³ of NaOH, which was used in the previous experiment, ये वाला original NaOH, ठीक है, that was reacted and it required this much HCl. So how much HCl was required for that? कितना बन रहा है? That's 39.
0.0784.
So again 0.0784 moles, right? So that means your original NaOH had these many moles, 0.0784 moles. So that means your original NaOH over here had 0.0784 moles. जिसमें से there's 0.059 moles left at the end of the reaction. So से steps में वही पूछा भाई, saying कि first find out the moles of NaOH that are in your original sample, and then calculate the amount of moles of NaOH present in the NaOH that remained after boiling. तो वो ये हो गए. Then he's going to ask you, okay, what is the amount of NaOH that actually reacted with this? So this is what you added, and this is what is left at the end.
So it's 0.0194 used.
तो यहाँ पे it's 0.0 कितना?
0.0194.
After subtracting the 2, you added 0.0784. 0.059 is left at the end. So that means 0.0194 is used. And it's 2:1. So iska half karo, you'll find the moles of NH4 to SO4. So what is the half of this thing?
So 9.7 times 10 power -3.
फिर उसे mass मांगी है, तो mass is multiply this by MR. So the MR of this thing is what? SO4 is 96.1. उसके ऊपर 132 बन रही है. 18 plus 18, that's 36. 36 plus 96, that's 132. 132.1 to be precise.
So it's 1.28 gram.
It's 1.28 grams. And then he's going to ask you, okay, what's the percentage purity? So how much mass did you use? You used 2.96 grams of fertilizer, right? So there's 1.28 grams out of in the 2.96 grams of fertilizer times 100. The percentage aa jayegi aapke paas. So what do you get for this?
43.2%.
Kitna? 43.2.
2.
43.2%. अच्छा, तो remember एक मेरी जो advice है ना, वो ये कि if you do all the latest papers, there's a lot of inorganic, there's a lot of organic. ठीक है? And अगर predict किया जाए ना, you're probably going to get a lot of organic and inorganic as well. लेकिन थोड़े से ना बीच में, just to be prepared, maybe they might ask you a lot of physical, ठीक है? Just in case, क्योंकि पहले भी उन्होंने बता के तो नहीं किया था जब when they change the pattern, they don't tell anyone, ठीक है? So maybe, just maybe, you might get a lot of, do a bit of a few old papers, ठीक है? Like really old papers, 2012, 2013, 14, where you have a lot of energetics, you have a lot of KCKP questions, you have a lot of atomic structure, ionization energies, a lot of moles questions, ठीक है? Big moles questions. So just to be on the safe side, ठीक है? वो थोड़ी सी practice कर लेना. तो कल फिर करते हैं, ठीक है? कोई और specific बात तो नहीं पूछनी.
So the definition list you sent, all the definitions in red are for next year, right?
हाँ, the red one is for A2, ठीक है? Remember that.
Okay. Okay, sir.
चले, okay. ठीक है, अल्लाह हाफिज़.